All right, welcome back. So we were in the middle of talking about L'Hopital's rule, so let's just keep going with it. So I'm looking at this problem. I kind of like it. Okay, we'll see. But right now, I'm looking at it like, yeah, this is a reasonably good problem. So what are we doing here? Let's check. Okay, always the first step. Let's check. Okay, so what do we have? We have limit x squared to 0. Right? And what do we have? We have a 7 plus x, ln x plus 1, 7 plus x, ln x plus 1, all over. Let's check this out. We have e to the x minus 1. All right. So what are we doing? Okay. So we have 7 plus 0. That's plugging in the 0 here. We have natural log of 0 plus 1. And we have e to the 0 minus 1. So simplifying this a little bit, we have 7, right? 7 minus 0, 7 plus 0 is 7. We have the natural log of 1. And then we have e to the 0, which is 1 minus 1. What's the natural log of 1? 0. Hey, would you imagine that? You have an indeterminate form here. Okay, so great, we have indeterminate form. Now, let's go ahead and take our derivatives, okay? So again, we're going to take the derivative of the top and the derivative of the bottom, right? Now, the top in this case does have a product rule in it, all right? So you got to be a little bit careful about that. So remember the product rule, right? This is the derivative of the first times the second plus the first, 7 plus x, times the derivative, let's do it this way, ln x plus 1. And all I'm doing is setting it up here. We're not really taking derivative yet. Okay, I'm just laying out my plan. And then on the bottom, right, we have e to the x. There's no more minus 1 because we took the derivative. Okay, so this one is taken. Okay, what is the derivative of 7 plus x? It's 1. Okay, so we have 1 times natural log x plus 1. Okay, plus 7 plus x, parentheses. What's the derivative of natural log x plus 1? It's 1 over x plus 1 times 1 for the chain, right? Divided by e to the x. All right, so let's see what we have here. If I just go ahead and plug in a 0 here, okay, we're going to have 1 times natural log of 0 plus 1. Well, that's 0, right? Plus, and then here we have 7 plus 0 times, right? So the 7 plus x is on top, and we have 0 plus 1 on the bottom there. Okay. Divided by e to the 0. Okay, well, this bit here, okay, this bit here is going to be natural log of 1, which is 0. So this part's 0. And then here it looks like we have a plus 7 over 1. Okay, divided by e to the 0, that's 1. That is no longer an indeterminate form. Better yet, that's not even an indeterminate form. That's a limit. We're done. Okay, so that's 7 over 1 over 1, which is 7. Okay, so yeah, I kind of do like that problem. Not quite so much because it's too easy to guess, right? It's too easy to guess. So you look at this and you say, oh, that's 7. So maybe, but something like that is, reasonable question. Okay, there's some stuff to do here. Okay, let's check our answer. And we'll go to the next question. So, you know what I'm going to do? I know I did that, but I'm going to set my timer so that I have even a chance of finishing on time. Okay, this one. Okay, good problem again. How are we doing here? Which problem is this? This is number 7. Okay, so let's see what we have. So this was a limit as x approaches infinity. Okay, and remember all your other limit rules still apply. And you don't have to use L'Hopital's if you don't want to, but in some cases, I think it's the best thing to do. Okay. Actually, in most cases, it's the best thing to do. As long as you get this indeterminate form, it's a very, very powerful rule to be using. So if I plug in my infinity, right, we get e to the infinity, which is infinity. Natural log of infinity is infinity, right? You know what the graph of natural log looks like, something like this. Okay, and on the bottom we get 3 times infinity, which is infinity. Okay, looks like an indeterminate form. We're set. Okay, and even though I know your book doesn't lie to you, humor me. Okay, humor me in going ahead and checking your indeterminate forms. Okay, I lost a significant amount of points on one exam not doing this. Okay, it wasn't even a L'Hopital's exam. It was like an exam in the next class. So humor me. All right. So let's go ahead and take our derivative. So what is the derivative of natural log of e to the x plus 1? Right. Derivative of 3x, you could do that. It's just 3. Okay. So remember, right? It's 1 over u. It's 1 over whatever this is. So 1 over e to the x plus 1 times the chain rule that's going on here. So we have to take the derivative of e to the x plus 1 like that. Okay, so divided by 3. So this is going to be 1 over e to the x plus 1. Okay, and then what is the derivative of e to the x plus 1? It's e to the x. Okay, divided by 3. That looks delightful, doesn't it? So what do we have? We have e to the x over e to the x plus 1 over 3 over 1. Right, so this is simply, right, e to the x over 3 e to the x plus 1. Okay, now if we go ahead and check again, okay, we can. So go ahead and plug in your infinity over infinity here. So we get e to the infinity, which is infinity. And then we have 3 infinity plus 1, which is still infinity. And we get infinity over infinity. And we have indeterminate form. Okay. Now, pull the 3 out for a moment. Okay. We just have e to the x over e to the x plus 1. Okay. If I take the derivative of the top, what are we going to get? E to the x. I take the derivative of the bottom, we end up with e to the x. Okay. Not that bad. So here's my 1/3. All right. So here we go. And we can cancel these, right? And then it looks like we're about set. Okay. Let's take a look at the problem here. Again, might be able to guess this one, but I kind of like it. You know, as far as problems go, I kind of like this one. Okay. You have to do, don't have to do L'Hopital's twice, but there is something. You do have to do it twice. Okay, there is something to it. All right. So I do kind of like it. If you didn't want to use L'Hopital's here, I was expecting not to have to use L'Hopital's at the top here. We have x, we have 1/3, and we have e to the x plus 1. What I was expecting to do is to multiply by e to the x, e to the negative x, and get 1 over 1 plus 1 over e to the x. This would go to 0. Okay, 1 over e to the x as x goes to infinity would be 0. And then we'd have 1/3 times 1 over 1. Okay, so I was expecting that to be the problem, but it turned out L'Hopital still worked. So what the heck, why not use it? And we're ready to go. Okay, so this was 1/3. Let's go ahead and check. Fingers crossed. Okay, fantastic. All right. So it's not a given I get these problems right, by the way. You have to check too. All right. That was 7, but like I said, that's kind of a good one. I like that. Okay, so let's take a look at that. Let's take a look at 8. Messy, but reasonable. Yeah. Oh, man. Let's see what we got. What time is it? 5 minutes, 10 minutes. Okay. Explain what is wrong with using this calculation. Clearly, right, we get the 0 over 0, we get 0 over 3. So here's an example of where it's not going to work. Okay, it didn't give us an indeterminate form. Okay, which if I asked you something like this and didn't give you multiple choice, it didn't follow indeterminate form would be the correct answer. Okay, the fact that this equals 0, infinity, or whatever, that's great, but this thing, as x goes to 0, this is 3. So we're not, so we won't ask you that one. Let's see, question 9, question 10. Is that the last one? That is the last one. Let's see what we have here. We assume that s of 0 is 1 and s of 1 is 0. Explain what this assumption means. Let's see. Okay, so let's see here. What we have s of b. This is actually not a bad problem either. S of b over 1 minus b. Okay, but we have to do some reading to figure out what we're doing here. Okay, so study the population dynamics in historic China, which defines B as the ratio of bandits to civilians. Okay, peasants and rulers. And S of B is a measure of how successful the peasants are in fighting the bandits. Okay, so this is all looking at the ratio of bandits to civilians. Okay, so if we have 1 to 4, right? That would be, so if I guess 4 would be 1 bandit to 4 civilians. Okay. And S of B is how effective the peasants are in fighting the bandits. Okay. So let's see here. So it is assumed that S of 0 is equal to 1 and S of 1 is equal to 0. So the ratio of bandits to civilians. S of 0 means there are no bandits, right? And a bunch of, oh no, it's assumed S of 0. Oh, S of, okay. So the ratio B, there's no bandits and there's all civilians. So S of B is a measure of how successful are the fighting the bandits. If there aren't any bandits, the peasants are extremely successful in fighting the bandits. Okay, and then here, S of 1, this would be there are as many bandits, right, as 1, or as many bandits as there are civilians. So let's write that down. S of 0, B equals 0 means 0 bandits to however many settlers you want, how many civilians you want, to n civilians. Okay, so 0 bandits and to n civilians. Okay, I ask my D&D group a lot of questions about how we're supposed to kill monsters, because I used to play a lot in the 80s, but things have changed since then, and now I don't know anything. But when they say you can't know that, like I asked them, like, in real life, how do you kill a vampire? And everybody knows how you kill a vampire, but there are no vampires. So as a civilization, we are extremely effective in fighting vampires because there aren't any. Okay, so our S of 0 is equal to 1 means we are 100% effective at destroying vampires because there aren't any. Okay, so in this case, the civilians are 100% effective in dealing with their bandits. Okay, they always win because there aren't any. All right, now, and then they're saying S of 1 is equal to 0. Okay, so in this case, well, a B of 1, right? When B equals 1, that means there are as many bandits as there are peasants, as there are civilians. Okay, so if you have 100 bandits, then we have 100 civilians. 100 to 100, right? That cancels, and we get 1 over 100 to 100, which is 1. Okay, we have a ratio of 1, and we're saying that in an even fight, bandits are going to absolutely slaughter the civilians. Okay, and I suspect that would be the case with vampires too. If we had as many people as we had vampires, there wouldn't be a lot of people left. Okay, after that first bit. Zombies, same thing, right? So yeah. So that's what they're saying there. Okay, so S of 1, okay, S of 1 equals 0 means civilians are 0% effective in fighting off bandits. Okay, so there we go. So let's see what we got here. The assumption arises from defining the scale. So S equals 1 corresponds to what? Oh, let's see what they tell us. Yeah, maximum failure on the part of the peasants. Okay, so if we had to fight vampires, we would be fodder. We would be the cows. Okay, and a 0 corresponds to absolute success. Okay, S equals 0 corresponds to absolute success. Presumably, when the number of bandits equals the number of civilians given by B is equal to 1. Okay, probably shouldn't have walked us through this. Probably too much. The value of B, okay, the civilian population is completely over 1. Value of B equals 0, right? 0 bandits to sorry, 0 bandits to civilians would be the most successful. If we don't have any vampires, then we are really good at fighting them. And let's see how we did. One or more responses incorrect. We don't like that. Okay. Let's see. S equals 1. Oh, no, S equals 1. Oh, no. S equals 1 equals 0. So that assumption means we have maximum failure. S equals 0 corresponds to maximum success because we have S of 0 is 1. So like this. Presumably, once the bandit numbers equals the number of civilians, 1 to 1, then the civilian population is completely overrun. What did I get wrong? I'm sure you guys are watching this. It's really obvious. Okay. Doing this. Okay, one more try. Let's see. Okay. Correct answers are 1 and 0. Your answers are 1 and 0. Whatever. Okay. So understand that you know, they're gonna be whatever here. Okay. Let's go back and look at one of the problems that we didn't do. Yeah, I'm sure. Okay, let's take a look at this one and see what we can do. So note when you guys get to that problem, be a little bit more careful than I was, and hopefully they'll interpret it in a better way for you. Okay, so let's see here. Okay, but if you're getting it wrong, like realize like, you know, we're all beta testers. Okay. So here we have limit as 4x over x minus 6. Is that a minus or a plus there? Minus 4 over ln, what do we have? X over 6? X over 6. Okay. And we want the limit as x goes to 6. So in its current form, right, it's not actually something you use L'Hopital's on, because as x goes to 6, this is 24 over a mass, right? Minus 4 over a mass. Okay. So we got to get common denominators. And what I mean by that is we're not using that part. Okay. We got to get common denominators here because we got two fractions subtracted from each other. Right? So we have 4x over x minus 6 minus 4 over ln x over 6. How do we get common denominators? Well, we're going to say this is x minus 6, x minus 6. We're going to say natural log x over 6, natural log x over 6, right? So here we have it. We have 4x ln x over 6 minus, and then here we have, right? We have 4x plus 24. We're going to have minus, minus, it's positive, and then divided by, what do we have? Well, we have ln of x over 6 times x minus 6. I should have written this before because that's how we do it. Okay. In this case now, now we check, right? What is the limit as x approaches 6? Well, here, right, that's going to be 0, right? So if I plug that in, that's going to be 4. It's going to be 24 times the natural log of 6 over 6, which is 1. That thing is 0. Minus 24 plus 24 divided by natural log of 6 over 6, which is 0. Natural log of 1 is 0. And then we have 6 minus 6 here. All right, it's a little overkill. So let's go on and see. All right. So we do get a 0 over 0 sort of a situation. So it is an indeterminate form, and we can go on and make more of a mess of things with L'Hopital's. Okay. So we have to figure out how to take this derivative, right? We want to take the derivative of the top, we want to take the derivative of the bottom. Well, fortunately, we don't have to deal with quotient rule here, but we do have to deal with product rule, okay? Specifically here, we have product rule. Here, we have product rule, okay? So be careful about this. So remember, it's going to be, here we go. So this is derivative of the first, so 4x derivative times the natural log, x over 6, okay, plus 4x times natural log x over 6 derivative, okay, minus 4x derivative plus 24 derivative. Because these don't have multiplications of times on them, so we just take the derivative piecewise, right? Great. And on the bottom, we've got another product rule. So we got the derivative of x over 6 over x, right? X over 6, that's it. Okay. Sorry, let's keep it in the right order. Okay, this is x over 6. And derivative of the first times the second, x minus 6, plus the first, x over 6, times the derivative of the second. Okay, so all I've done, because this is a complicated problem, I've laid out my plan. All right, that's all we did here. It might be nice, like, why don't we work off to the side, like, what is the derivative natural log of x over 6? Okay, so remember, the derivative of natural log is 1. So remember, this, we have this, right? The derivative of natural log of u is equal to 1 over u du. Doesn't strike me as a bad way of going about this, right? If we set u is equal to 1/6 x, what's du? That's 1/6 dx, isn't it? Okay, so why don't we just use that and figure out a derivative here? So this derivative, right, is 1 over our u, which is x over 6. Okay, times dx. What's our dx? Our dx is just 1/6. Put this off to the side. What is the reciprocal of x over 6? Wasn't it 6 over x? Okay, times 1 over 6. That's my du. Bring it back in. This cancels, and we end up with a 1 over x. All right. So the trick for a lot of doing the harder derivatives here is just to break them up, so you don't have to stare at that one big scary thing the entire time you're doing the problem. You can break it up, work this as kind of a mini problem. Then we can go back here, say, okay, what's the derivative of 4x? Right, back. Well, that's 4. Okay, and we're not touching this because it's just natural log of x over 6. Okay, I'm sure that's delightful. Okay, and then we add 4x, so plus 4x. And then what is the derivative of natural log of x over 6? It's 1 over x. Right? What's the derivative of 4x again? It's minus 4. Okay, and what's the derivative of 24? 0. Right? Now, what about the bottom? Derivative of x over 6, natural log x over 6. See, this was going to come in handy. this 1 over x, right? And then this is x minus 6. All right. And then plus natural log x over 6 plus natural log x over 6. Okay. And then we need the derivative of x minus 6, which is just 1, right? Because there's no powers on x, it's just x. Okay. So there we go. Let's clean this up a little bit. Okay. So here we go. We have 4 natural log x over 6. So we have 4 ln x over 6. And do you see that this 4 and this negative 4, that's going to cancel, right? That this business here, if these guys are going to cancel, we're just going to have a 4 minus 4, right? So that's our top. We're done there. Okay. Hopefully this will crack the whole thing. Probably not, but you never know. It's 1 over x. Okay. X minus 6. And then we have plus natural log x over 6. Okay. So let's check. Okay, let's check. As x approaches 6, right? Well, we get 4 times natural log 6 over 6, which is 1, right? And natural log of 1 is 0. So the top is 0. Okay. What about the bottom? Well, we get 1 over 6 times 6 minus 6, so 0 over 6, plus natural log of 6 over 6, which so we get a 0 plus a 0. So that's great. Again, check. We are in indeterminate form. We're ready to go. Okay. This looks marginally less terrible than what we had before. Let's clean it up a little bit. Okay. So here we have 4 natural log x over 6 divided by, can I multiply this? Can I say that this is 1 minus, how about we go 6 to the negative 1, right? Because we're multiplying it in through this, so that's going to be a 1, and it's going to be 6 over x, which is what this is saying, okay? Plus ln x over 6, okay? Now, we're going to apply L'Hopital's here, okay? So we need the derivative of the top, that's 4. What was the derivative of natural log of x over 6? Wasn't that just 1 over x? Okay. And then divided by, well, that's these are a product rule, right? Or not a product rule, our chain rule. So that's 0, right? Derivative of 1 is 0. Bring this down in front, so that's a positive 6 because the negative times the negative is positive. X to the negative 2 plus, what's the derivative here? Right? What's the derivative of x over 6? Natural log x over 6. Wasn't that 1 over x? Okay. We got to clean some stuff up. Okay. So this is 4 over x here divided by 6 over x squared plus 1 over x. Can we multiply this by x over x? Sure. So what are we going to end up with? 4 over x over 6 over x squared plus x over x squared. Okay, so there's a lot of algebra in here. Like all of a sudden, like everything you ever forgot about intermediate algebra is coming flooding back to you, and you have to deal with all of this. Okay, and this is right x plus 6 over x squared. So you got a fraction on top of a fraction. You remember doing these, right? Aren't these fun? Right, there you go. By the way, for the people that are, you guys are getting close to done with your math requirements. Like, I got some bad news for you guys. Okay. Most of the people you're going to work with are not so great at the math, and it's going to be left to you, okay, to be the person who's good at math. I know that is a frightening thought. Most of the time, it's stuff like this about how to deal with fractions of fractions, okay? So we both know, right, when you get a really tricky calculus problem, like, well, the reason why we do this is so I can identify the tricky calculus problem. Like, this got out of my league. let's go find an engineer, let's go find a mathematician, let's go find somebody who can do this. But a lot of the stuff is like, you're going to be the expert. I'm really sorry to tell you that. Okay. I'm not, but I kind of am. Okay. So limit as x approaches 6. And we have 4 times 6 over 6 plus 6. So we have 24 over 12 is equal to 2. Man, I like this problem. I feel guilty about giving you this problem on a quiz. Okay, it's too much. There's a lot of, we'll see. When I type this in, we'll see, because I don't know if it's going to be right, because there's a lot of places to make a mistake with algebra, isn't there? Hey, look at that. Okay, so I would feel a little bit bad about giving you a problem like this on a quiz, because there's too many moving parts and there's too many places to mess up. So number 8, I would say this is a good problem to do as a homework problem. This is not a good problem to take as a quiz question. Okay, there's too much. But the ones where we didn't have as much to do, maybe, I don't know if I like it too much. But something like, something up here, definitely something like this. And I would say that those were pretty good. Okay. But the one we just did, like there's too many things moving, there's too much stuff to keep track of, and there's too many places for you to make a mistake with this. So what am I grading? Right? And that's what I have to contend with, is like, are you grading the skill that you tried to teach, or are you grading like the morass of algebra they probably got lost in halfway through the problem? Okay, so if you're not getting this one, it's not the end of the world. If you take a couple of times to get it, it's not the end of the world. I'm not going to be looking at this like this is the quiz question. It's not. This is terrible. Okay, you want to look at, like I said, you want to look at this 7x natural log x plus 1 e to the x minus 1. Like, oh, good problem. Okay, this one not so bad, but it's kind of easy. This one's a little bit easy. Okay, so if I'm kind, I'll probably pick one like that. I still like the fact that the answer comes out to be 1 over 14, because it's not something you're going to be looking at and saying, oh, of course it's 1 over 14. Okay, you're going to have to actually solve it. Whereas this one, you said 1/3, like I wouldn't exactly know how you got that. Okay, I expect you to work it out, but at the same time, you kind of know. Okay. But there you go. All right, so I'm going to leave it there and start the next section, and then that's probably way too long. Okay, let's sign out.